Hi everyone, my name is Steve. I'm a training advisor from Alibaba Cloud Academy. Today, I will introduce Alibaba Cloud Container Service and Container Registry, two products to you. Also, I will help you to understand how to use these two products to do application deployment and build up your first simple CI/CD pipeline. Here is today's agenda. At the very beginning, I will introduce cloud-native industry trends and challenges. Then I will do a brief overview of Alibaba Cloud Container Service related product portfolio. After that, I will majorly introduce container service on Kubernetes and container service registry features and application scenarios. At the very end, I will show the console demo of what ACK and ACR looks like and how to use them to build a simple continuous integration and a continuous deployment pipeline. Finally, there are some use cases sharing. And this slide shows, by 2022, more than 75% of global organizations will be running containerized application in production. That is why we are seeing that in the future, cloud-native application will become the new normal. But this kind of industry trend wasn't happening in one day. Started from year 2000 with the virtualization technologies, we saw more and more IT devices are being virtualized into shared resources, especially the computing service. We began to see virtual servers more and more, and a lot of tools and utilities were developed to help those servers being transferred from physical form to virtual form. Then when time reached to year 2015, to achieve more faster and lightweight virtual computing unit, container technology was adopted more and more in enterprise application development and operation. And nowadays, with container technology support, more and more companies are willing to offload their operation work to cloud service provider and focus more on business logic application development. So function compute and serverless are becoming the current wave of application cloud-native transformation new trend. But actually, no matter how the cloud-native industry trend is evolving, the common IT challenges are always the same. The challenges every company wants to overcome including, firstly, how to increase the resource utilization to save the cost. We can call it elasticity challenge. Secondly, how to use the serverless cluster for applications running with bursting workload. We can call it serverless challenge. The thirdly, how to centralize, monitor resource usage and system event with logs. We call it observation challenge. And fourthly, more and more enterprise are using hybrid cloud and multi-cloud. How to easily manage hybrid cloud or multi-cloud environment is another common operational challenge. Now, let's take a deep look at Alibaba Cloud Container Service portfolio to see how Alibaba Cloud using container service and container registry to solve about challenges. Alibaba Cloud Container Service are built on top of Alibaba Cloud IaaS capabilities for public cloud, private cloud, and edge computing, and integrated computing, storage, network, security with optimization. There are two offerings for Kubernetes service. One we call the managed Kubernetes. Sometimes we call it ACK, Alibaba Cloud Container Service for Kubernetes. And another is the serverless Kubernetes. We call it ASK, which I will talk about some details later. ACK provides the secure, scalable, and stable container platform based on Kubernetes. It provides end-to-end security capabilities, end-to-end observability, just like logging, monitoring, tracing, and automatic operation and management for cluster lifecycle, especially for auto-scaling and auto-recovery. Definitely, there are some other features I will talk about later. We also provide the Alibaba Cloud Container Registry service. For cloud-native application asset management, just for example, you need to manage your Docker image and Helm chart. For cloud service integration, also we support open service broker API for the cloud services. So based on Kubernetes, customers can run different kinds of application workloads like the microservice. In Alibaba Cloud, we have Dubo, and also you'll be familiar with maybe Spring Cloud. And more people are running the stateful middleware, just like MySQL readers and also. You may seldomly say that actually we can run big data and AI applications on Kubernetes also. Actually, the Flink, the TensorFlow, those kind of service of Alibaba Cloud are running on top of ACK. Furthermore, there are other many innovative applications, just like the blockchain, like the IoT. It can actually also can be run on top of ACK. Also, Alibaba Cloud is very active in cloud-native related community and contributed a lot. So we are initiative members of Open Application Model. Also, we are the platinum member of CNCF. We are also certified Kubernetes service provider. And one of the Alibaba Cloud team member named Li Xiang is also selected and a member of CNCF Technical Oversight Committee. Okay, now let's look into more details about ACK and ACR, and as I said, how to use them to solve the common IT operational challenges. Alibaba Cloud ACK service is running on clusters. So customers can create a cluster through our different templates. So from operation easiness aspects, you can choose between managed cluster, dedicated cluster, and serverless cluster. From hardware aspects, you can choose cluster using GPU, NPU nodes, or bare metal nodes. And from application scenario aspect, you can choose edge computing cluster, confidential computing cluster, even with cluster running on Windows operating system. But if you have so many kinds of clusters, how can we more differentiate it from the operational point of view? So here is a more detailed comparison between dedicated, managed, and serverless clusters. So dedicated cluster, so both the master node and worker nodes are managed by the end user. The managed Kubernetes cluster, the master node is managed by Alibaba Cloud, and the worker node is managed by the end user. And comparing to serverless Kubernetes, the both actually master node and worker node are managed by Alibaba Cloud. So from this difference, you can tell that serverless Kubernetes can save you a lot of operational difficulties and complexity, and you can focus more on your simple IT operations. Okay, now let's compare managed dedicated Kubernetes cluster with serverless Kubernetes cluster from the computing nodes they are using. And we can see for managed and dedicated Kubernetes cluster, pods are running actually on the ECS, or sometimes we use EBS, the ECS on bare metal, and also we can simply scale up to the ECI. ECI is our elastic container instance. So the managed and dedicated Kubernetes cluster is more suitable for application scenarios like cloud boosting, large-scale batch processing, and hybrid elasticity support. For the serverless cluster, all workloads are running on our elastic container instance. The scenario for application running on serverless cluster is like Presto, Spark, we call them the data processing, and also Jenkins, the GitLab runner. It is for the CI/CD pipeline speeding up. And put this in your mind, the serverless cluster also we support the Spot instance and GPU instance. For storage, if you are running stateful application or database in Kubernetes cluster, you can choose our cloud disk and persistent volume. But if you want to store logs or share file level data to others, you can use our NAS, and Docker persistent volume. And for more genetic data or media files, like the OSS can be a better choice. More than these three commonly used storage types, you can also use CPFS and persistent volume for the high performance computing or the deep learning, those kind of scenario. And if you're really looking for high speed, high IOPS throughput, you can use local disk for the better IOPS if your application needs to access data on disk very frequently and quickly, just like a database or Hadoop. After you create a Kubernetes cluster, you can select either Turway or Flannel and the network plugin. So Flannel is a simple and stable container network interface. It is developed by the community. When combined with Alibaba Cloud VPC, Flannel provides a high performance and stable container network. However, Flannel only provides a few simple features and does not support standard Kubernetes network policies. Instead, Turway is a network plugin developed by Alibaba Cloud Container Service. Turway enables you to assign Alibaba Cloud ENI to containers and define access policies between containers based on standard Kubernetes network policies. Besides that, Turway supports bandwidth throttling on individual containers. If you do not need to use network policies, you can select Flannel and the network plugin. Otherwise, we recommend you to select Turway. For cloud native security, we provide end-to-end security in infrastructure layer first. We support fine-grained RAM authorization for pods, and we provide also in the software supply chain layer, including the image signing, image scanning, and also we support the secure distribution of those images, etc., to make sure the software can be securely protected during the supply chain delivery. And for the runtime layer, we provide network policy, runtime defense, sandboxed containers, etc., so that we can protect application runtime security. Regarding extreme elasticity, we provide two-level scaling in Alibaba container clusters. First one is resource scaling, and second one is application scaling. For resource scaling, it can be scaled up or scaled in with ECS, so ECS on bare metal, the GPU, and even spot instances, and even the virtual node using the ECI. And for application scaling, we support HPA, the horizontal pod autoscaling, the VPA, the vertical pod autoscaling, and cron job-based horizontal pod autoscaling. And for the HPA, it can be triggered by external metrics such as the QPS or the website latency, etc. Now let's talk about Alibaba Cloud Container Service Cluster end-to-end observability. So we know in observability, it has three pillars: the metrics, tracing, and logging. Alibaba Cloud has many services mapping for the logging metrics and tracing. All those services are seamlessly integrated with ACK to make you easily observe your Kubernetes cluster and monitor your applications. You can find some familiar product names like Cloud Monitor, Log Service, and ARMS, and ARMS Prometheus. Those are all the products we can use to trace and log and monitor your applications. Okay, for the AI and big data scenario, we provide heterogeneous computing. Make you simply build CPU, GPU, FPGA, RDMA, and storage for the machine learning and big data fundamental environment. We support major machine learning frameworks such as TensorFlow, MXNet, Caffe, etc., based on the Kubeflow. For increased resource utilization, we optimize Kubernetes scheduling strategy to make pods can be tied on the GPU nodes. They also have something called the shared GPU capabilities, and we provide the GPU isolated functionality. We also developed something called the co-scheduling and capacity scheduling strategy, and this kind of technology is developed by Alibaba Cloud, and we contribute back to the community. So on top of that, we provide one of our product called Arena, so which is a command line tool to make you easily run machine learning jobs. And this special tool is also initially developed by Alibaba Cloud. We also contributed them back to the Kubeflow. Regarding hybrid cloud or multi-cloud management, the three types of solutions are very popular. The first one is active-active. The multi-clusters running on cloud and IDC respectively, and you can leverage the federation to manage the multiple cluster CI/CD platform to deploy applications to cluster, and using something called the Global Traffic Manager to manage the global traffic. The second one is called Autoscale to Alibaba Cloud, so the major application running is on the IDC. So when the application needs scale, it can auto-scale into Alibaba Cloud. And both services, they need to register themselves to the same microservice registration and discovery gateway. The third one we call the ACK multi-cloud management. So ACK multi-cloud management is able to manage clusters and same as ACK cluster, and no matter the ACK is from IDC or from other cloud, they can register themselves into ACK. So the registered cluster can be using our log service or ARMs, the application real-time monitor, or ARMs-Prometheus to log and monitor both the clusters and the applications running on those clusters. So here I'm giving you an example for cloud-native high available application architect. So you see the Kubernetes cluster, they were deployed in the multi-zones. Now we have zone A and zone B. The nodes are distributed between the different zones to achieve the high availability. And using the SRB and the front end to distribute it, the incoming traffics. And also you see on the back end, we are leveraging our database. It's called PolarDB. It's also a cloud native database to handle the data part. And also with the log service and the ARMs, Prometheus, monitoring and a dashboard, we can keep continuously observe applications and also the Kubernetes cluster. Okay, let's talk more about another cloud native product. Together with Alibaba Cloud Container, we want to introduce Alibaba Cloud Container Registry to you. Especially today, I will introduce the Enterprise Edition. We provide an enterprise class secure service to manage your Docker images. It is designed for enterprise customers that has high requirement for the security, also deploy their service in multi-regions. Sometimes our customer may use our container cluster with a large number of nodes. So Container Registry Enterprise Edition is further divided into Basic Edition, Standard Edition, and Advanced Edition. And we call them the ACR+ACK. Okay, ACR+ACK supports cloud native artifacts. We provide a dedicated strategy instance with plugin mechanisms to support multiple architects. So you can manage the container images, including Linux, Windows, and ARMs, and we will support full lifecycle management of Helm charts, version 2 and version 3. It also provides a multi-dimensional security guidance, including the user-defined domain and the network ACL. Also, we have something called a server-side encryption for storage and vulnerability scan and analysis. Besides the security features, we also enable large-scale distribution and a policy-based global distribution for enterprise to accelerate their time to develop or to deploy their applications. We also provide P2P based large-scale image distribution over the, more than 10,000 nodes. It can actually speed up image pooling to 1 second through snapshot. We also provide policy-based image replication across different regions. The replication efficiency is actually improved 7 times. With ACRE, you can do a lot of things. Firstly, let me introduce how can we build up a secure software pipeline. With the cloud-native delivery chain, the container registry can automatically scan the new container images after pushing. So if the image meets the criteria defined in the chain blocking policy, the system may automatically block the risky image to deploy. So otherwise, the system process will follow up. We will proceed with the following steps. So the chain with image security policy guidance guarantees the images are safe enough to distribute, and the ACR will automatically sign the image by our KMS, Key Management Service, privately. And in the ACK cluster, we will validate the images by the public key provided by the KMS to automatically verify the image signature. So if a customer deploys an unsigned image in ACK cluster, the cluster will prevent this unsigned image from being deployed. And also we have a product called the Security Center. It also can do the runtime protection in ACK clusters. So this is actually an end-to-end security solution for ACI to build a secure image producing pipeline. So all in all, Alibaba Cloud Container Service contains rich portfolio of products. You already saw the Alibaba Cloud Container Service, the ACR. So with this product, you can build up your secured and managed or serverless Kubernetes clusters. And also with different kinds of the ECS incident support and cloud storage volume support, you can run different kinds of applications on your cluster with extreme elasticity and extreme performance. So this slide is showing you the information published by Gartner comparing the different public cloud container service provider. Here they are comparing between the Alibaba Cloud, AWS, Google, IBM, microservice, and Oracle. So compared from 6 criteria. So we can see ACK, Alibaba Cloud Container Service, has rich products and technical layouts. You can tell from the table that the Alibaba Cloud Container Service for Kubernetes has very comprehensive features and also a very competitive pricing. Okay, now let's show you some console demo to show what a real ACK and ACR looks like and how they can work together to build CI/CD pipeline. Okay, now let's take a look at the first demo. So here you are looking at is an Alibaba Cloud Container Service dashboard. And if you want to create a container service cluster, you can go to the clusters here and click the button Create Kubernetes Cluster. You will see different types of cluster and are introduced in the slide. You can just pick up one of the cluster you are favorite and click the Create. Then they will lead you to this kind of dashboard, and remember we have a different cluster types you can pick up, right? So this is the dedicated edition, and let's say just give a name, demo, and using the Singapore region. And this is the Kubernetes version. You can pick up the latest version, and the container runtime, usually Docker is our choice. And the VPC, if you choose VPC, you can see they will list the internal vSwitch, and you can pick them all. Remember, I introduced that for the cluster, you have the different network plugin you can choose. Then you can decide your pod CI/CD block and your service CI/CD block, and some other configurations, including the public access, and configure the SNet, SSH login. And if you have the RDS you want to whitelist, you can select the RDS instance, right? And also you can you can select the security group, right? So with all this kind of configuration, you can go next to the master configuration. Here, for the master node, usually it has to be a high availability configured. So 3 nodes is required. And if you want to put them in one of the instance in the different zones, you can select them. The different types of the instance can be picked up. All right, so you can select maybe just this one. So now I successfully put my 3 master node in 3 different zones. And then I can go to the worker configuration. For worker, you can using existing instance or create instance, and you can pick up also your preferred configuration for your worker node. The quantity of the worker node could be 1, 2, 3, usually at least 1 worker, I think. Then you can configuring your logon method, right? After you do this kind of configuration of the worker, you can go to component. This is about the volume plugin and some other services you want to connect with. So after you do all this kind of configuration, you can click confirm the order, and we will begin to automatically create the cluster for you. So in this demo, for the time reason, I will not create a cluster because I already have one. So what you are looking at is an existing cluster. It is a dedicated cluster. So if you click into the demo -1, you will see the dashboard of this cluster and the basic information, including the endpoint and the address block they are using, and some of the configurations you need to know if you want to connect from the remote using the Kubernetes control or the SSH to the one of the nodes. This is listing the resources the cluster is actually using, just like the SLB log service on some other things. This is about the logs, what's happening in the cluster. And if you click nodes, you will see they will exactly show how many master and worker node we have, and together with the cloud monitor functionality, you will see the CPU usage, memory usage of all the nodes, because each of this master and worker node is a ECS service actually, right? Then here is the add-on. Some of the add-on you can see already installed in the cluster, and you can also upgrade them if you want to. Here is the events happened in the history, and if you really want to upgrade the Kubernetes version, you can go here and check if you are running the most latest version we are supporting, right? Okay, so for this demo 1, there's a lot of functions you can directly apply to this cluster, including expand. Maybe you want to add more master node or worker node into it, right? And you can upgrade. You saw that function already. And auto scale, right? The auto scale means together with auto scaling, we are trying to give you a kind of very easy way to scale up your instances, right? So you can see based on some of the threshold criteria, you can create a scaling group and define your auto scale rules. Some other functions like check, auditing, and deploy the ISO, and even you can go to the dashboard. The dashboard gives you another way to view the details of your cluster. You see there's the service running, and the secrets, cron jobs is quite similar like we can see from the previous demo. So I'm going to go back, and here is listing again the node information, and I said if you go to the node pool, they are putting all the nodes together and have a more convenient management. So you can see they can scale out, add an existing node to the node pool, and for the persistent volume, you can create it based on Alibaba Cloud Disk and NAS service or the OSS. It is very well connected or integrated with Alibaba Cloud storage service. And the namespace is the concept of the Kubernetes, right? You can create the new namespace, and you can even authorize some RAM user to this cluster. And here, the concept of the deployment, stateful set, daemon set, this all the very basic concept of the Kubernetes. So you can always find it from the dashboard, including jobs, cron jobs, and pods. If you look into the all namespaces, you may see the pods which is running maybe by the system itself, right? So the persistent volume, we don't have any either. And also look into the services and the ingress. These are both the layer 4 and layer 7 accessibility to the Kubernetes services, right? And also we support service mesh, we support Knative to build up your function compute, the serverless kind of function on the Kubernetes. Also, if you are familiar with Kubernetes, the configure map is for the configuration management, and the security is for the some of the password management. And you can, from our marketplace, you can always find your Docker image, and also some of the other application you can install through the Helm. And even we can provide you a function called application center. You can, based on your cluster, to create some new application and to fulfill your automatically CI/CD pipeline. Okay, this is just a very quick go through of the cluster of our container service clusters. Then let's go to the next demo to show you how can you using our container service cluster and container registry to build a simple CI/CD pipeline. Okay, now let's look into the second demo. How can we use our ACK cluster and the container registry to build a CI/CD pipeline? Here, what I have is I have a simple repository which already put in the GitHub, right? And later on I will show you the simple code repository. And what I'm going to do is I'm going to set up this kind of pipeline that assume that I'm a developer here. If I change anything in the source code, if I do the push, I will trigger the code that was changed to the repository, and our ACR will monitor this kind of code change, and we will begin to do some automatically build of the source code. What it built out is actually a Docker image, right? And at the same time, the container registry will have a hook, the webhook connect to the ACK deployment, the Kubernetes deployment. And this kind of a hook, because of the new image build, will trigger the hook, and the deployment will receive this kind of notification and begin to redeploy the whole related new image and make the service being updated. Okay, this is the basically things we want to demonstrate. Now let's build it from the bottom. Firstly, let's look into the container registry service. I introduced this container registry service in the slides. I majorly introduced the enterprise edition, but the basic idea is the same. So container registry is the major place to store your Docker image. If you want to create a repository, you may need to do something like this. You create a repository, you pick up a proper namespace, and we call it maybe a simple web application, and make it public. Maybe simple web application. And let me put something like this, because I want to make sure I can remember the form of the IP address, form of this application. Okay, then we go to next. And now they are going to ask you if you want to bind a code repository to this image repository, right? So what we do is I'm going to go here to go to GitHub and make sure I have a repository. Actually, I'm going to show you is I do have a repository here. It's called Java Web Application Docker, and the build setting is I can automatically build images when the code changes, right? This is very important. And also build with the servers outside the mainland China to give it better speed. Later on, I will create a build rules. So I'm going to create a repository right now. Okay. So you see, I have a repository created immediately. Not this one, sorry. This one. So you see, they are telling me that this is my code repository, all the related information about how can I actually pull and push my images. To give you more details, I'm going to click here directly. They will lead me to the GitHub directly. This is my repository. You can see this is my profile, and the whole resource code repository is very simple. The main source code is here. It is a simple application, web application, and this is the index. If the application is running, you will see some of the some of the front page information will be shown here. And also in this repository, there's a very important file called the Docker file. If you click here, you will see the Docker file. Actually, this Docker file describes how can you build a Docker image from this Java code, right? So actually, they use Maven to copy the source code to the one of the directory, and then they just run the Maven to do the package build up, right? Then they copy the finished Java warball package to the Tomcat web application location. Then they expose the 8080, and finally they started this kind of application. So, but what we do is I'm going to simulate. I already have this source code actually checked out in one of my ECS servers. So you can see here all the files is a similar file in the repository. Later on, I'm going to change the file here. Right, you can see here this is one line front page. So I'm going to change this file, and this my change should be able to be reflected to the deployment automatically and immediately. But how can I achieve that? The way we do is I need to do something from the container registry first. So, and I said, firstly, you already have the source code, right? But you need to build it to generate your first Docker image, right? So you go to the build page here. You see they give you some kind of configuration about the build rules. So I add the build rules. So it is based on the GitHub branch. So I pick up the branch like the master, and my Docker file, you already saw it. It is from my root directory. So I put the dash here. The file is Docker file. I didn't change it. I can name it the latest, right? So this is my build role. What we can do here is actually very easy, because there is a build command here. You can directly click the build, right? You can click the build, and it will trigger a build directly, and you can monitor the log by refresh to see what is happening here. You see the build is started, and they are going to, based on the Docker file, and begin to prepare the needed software and doing the build, right? You see, this is what we define in the Docker file. They were actually trying to execute all these commands, right? You see. Okay, it might take a little bit time. Okay, that's very fast, huh? So now you see we have this kind of build successfully done. We have our first latest image build. I want to deploy this image to the container service cluster. How can I do that? I can click the deploy application directly from here. Okay, so I will tell him I'm going to generate internet access, and also I'm going to use the Kubernetes cluster, and click the deploy, and they will immediately lead me to the Kubernetes, to the container service dashboard. Right, let me call it simple web application default, and the class I'm using is demo1. The namespace is default. I'm going to create 2 replicas of the pods, and I'm going to do the deployment. So I can go directly to the next. So the image I can select directly from the container registry, and I said I'm using the simple web application. I click here, and the image version I only have the latest. I keep it the latest. And here the important thing is, no matter what kind of things happening, you should always pull the image, right? It means it always take up even the name didn't change, or the version didn't change, they always pull the images for the new deployment. So the other configurations you can change or modify, but maybe I just leave it as it is. But also you can see all this details information you can define from the command line. But our dashboard gives you more convenient way to do that. Then you can go to next. When you are doing the deployment, at the same time you can create a service so that it can be visited from outside. So I'm going to use the server load balancer, give him the public access, and create a new server, new SRB instance. One thing we do is we need to do the pod mapping, which means you need to know the container pod and the service pod do the mapping. Let's simply call it SVC, and XNO is 80, and Docker is 8080, right? Then you can click the create. This is my new service, and some of the HPA feature we don't need to change, and I can create directly. So now you see they immediately began to create a deployment and a service for me. And if you look into the details, you see 2 pods is already created and running. And if you go to the service here, you will see there's one service created for me. And if you go here and click this one, you will see because we need to add a simple web app here. You see, this is our front page is showing on the browser. So now I already deployed my first Docker image to the Kubernetes to become a deployment and a service, right? But this is not the end. I need to do something more automatically. And I said this demo is trying to show you how can you change one line of the code and push and commit the code and trigger the whole deployment to refresh the deployment. Now what we need to do is, there's still one thing we are missing, is how can I automatically trigger the deployment, right? So we already have this kind of code repository and build capability here, but how can I connect this kind of automatically build with the new image with this deployment? The thing is, if you go here, if you go to the deployment and you go to the details, right? There is one, one tag is called triggers, right? You see, they already have one trigger link give you here. You can copy the whole link, and this can be considered as a webhook. What we do is we go back to the container registry and go to the trigger here, and we create a trigger directly. It's called a redeployment, right? And we copy the URL here, and we click OK. So this is exactly connect the Docker image with that deployment, which means every time if you have a new build, it will trigger that deployment, and that deployment will pull the new image and do the redeployment. Okay, so now let's do the whole CI/CD pipeline. And I said I already have the whole source code in my ECS. What I can do is I'm going to do something like this. I'm going to vi source main web app index. It's a little bit slow. Sorry, not this one. It's a little bit slow. Okay, so I'm going to change the 1.0 to 2.0, right? It's simple, very simple change, and I save it. Because I'm in Git, I can click git add every change and git commit common change version to 2, right? And now I'm going to git push origin master is our branch name, and they will require you to enter your username and password. Oh, okay. Okay, I think I can do now. Okay, so now I'm pushing my change to the repository, and what happening here should be, you see, there's a new build was immediately triggered, right? You see something was building here, and if you go to the log, you will see, and before something was began to build again, right? You see they were going to running those kind of okay. So it's keep building, right? So let's wait a little bit time to wait for him to finish. See, now it is successfully built. What we want to try is directly go back here and click. You see, I refresh the front page, it's already changed to version 2. Okay, so now you get the idea, which is I just did one line change from the console, from the terminal, right? And finally the changes was reflected on the product environment like this. Okay, let me give you a quick recap of what is happening here. Remember, this demo is showing you that I'm a developer, right? I have some source code stored in the GitHub repository. It's called the code repository. And I usually, what I do is I do the git push and the pull and the commit to do the code change. But every line of my code change will be monitored by the container registry and will be built by the default build server automatically. And this kind of automatically build will also trigger the ACK deployment, because in the Kubernetes cluster we are registered a web hook, the deployment hook to the container registry, so that every time when the new build is detected, the hook will be notified, and the Kubernetes cluster will begin a redeployment to use the latest Docker image to deploy our service. That is why every time when you change one line code here, and in around, I think, 2 minutes, right? So the new service will be reflected in your product environment. Okay, this is my demo to the how can you simply set up the CI/CD pipeline with the container registry and ACK. Let's see some user cases. These are our real customers. This is a part of our customer around the world already using our ACK or ACR products. So you may find some very familiar brand here like Siemens, Olympic Committee, and Tokopedia, etc. So this customer, they actually implemented the idea of build everything and code. So from this chart, you can see those kind of red colors, those red color blocks I point out here is actually created by Terraform, and the blue color blocks are actually created by Helm. So everything and code here really reduce operation efforts and avoid the error could happen by the human interaction. So this customer is actually running the macro service on Alibaba Cloud. So the macro service is actually running on ACK, and it can expose the API through the API gateway. What we do is we also use some security products, if you heard of them, like the Wolf and Anti-DDoS, to protect this website. And also we have some files stored in the OSS and MongoDB. Also we use, remember, the log service and the ARMS Prometheus, those kind of products to observe the Kubernetes cluster and also the application running. And this customer, they were actually transferring their IT infrastructure from monolith to the microservice infrastructure. And the microservice is deployed on the ACK. Some files actually stored in the OSS also they use readers, Metrical, PolarDB, and InfDB to store the data and analyze the data. And the service can be accessed by website and also the application from the mobile application from the customer end. And this is the words quoted from their technical head. So by leveraging the solution proposed by Alibaba Cloud, we completed the re-architecture from monolith to microservices. It really shortened its time of our application development and deployment time. It reduced IT and resources expenditures and improved reliability and agility. So thank you very much for your time and looking forward to